Hello, my dear students. Welcome back to the lecture. So, in the previous lectures, we have discussed a lot of complicated beams, how the BBS has to be done and all. So here I thought let me add another one complicated, not general type of beams where the BBS has to be done, and then I'll explain you a few more general drawings, right? So just look at this drawing. So you can do the BBS of this. So what is the difference in the BBS of this is, see, previously whatever beam we used to take all was having the same depth, right? But here if you observe, we have two different depths. You can see this one, the beam depth is 200 by 600, that is this particular beam up to here. Okay, and after that the next beam whatever what I have, it is a 200 by 400 depth, and this is that beam. Okay, so now what will happen, since the beam depth is different, so your BBS remains the same. One small change will happen. We'll appreciate that. We'll try to understand that. So in case of top reinforcement, nothing will happen. This is your top reinforcement. Okay. Your bar will start from here. It will go all through. All through it will go and it will stop here. Okay. And can you read the number of bars? What it is required? It requires a 16 diameter 3 bar. So here it's a 16 diameter 3 bar. And here also it is a 16 diameter 3 bar. Here also it is 16 diameter 3 bar. That means from A, B, C, A, okay, there is no B. Okay. A, C, D, and E. Throughout, you are going to provide a 16 diameter 3 bar at the top. You can do the BBS of this because you know the length. This clear span, you know all the offset to be deducted. You can do that. Okay. That is not a problem. And also the top left extra, right extra can be done. Again, you can see you have to provide a 12 diameter 2 bar. That is a top left extra up to 1600 This also you can do. Similarly, if you come at the center span, you have to provide a top extra here of 1800 up the length, and it will be a 16 diameter 2 bar. Similarly, if you come on this side, again you are supposed to provide a 16 diameter 2 bar, that is additional, it's given. Additional means extra bar, you will provide it up to here, and then from here again 16 diameter 2 bar additional you are supposed to give. Those things you can do, but the main question is about the bottom bar. Now in the bottom, you see the bottom bar will start from here. It won't go completely. It has come here, and from here you see it has gone like this. Did you see this? Why it is like this? Why is that we are not taking the bar completely? The reason is about the depth. You see, this is 600 depth. That means your bottom will be here. This is my 600 bottom, and this bottom is 450. My 450 will be here. Getting top level will remain the same in the beam. If I seeing from the top, my 450, my 600 and 450 beam, from the top it will look at the same level. So that is why top bar I took completely. Whereas in the bottom, 600 will be here, 450 will be here. So you cannot take your 600 bar completely because your 400 is starting from here. So that is why what we do, you see this bar, this bar has come here, it has gone straight, then it has given the development length here. And next bar, this bar, what we do, we start from here. We started from here, we brought, and like this we are going to bring. We have to overlap it. Okay, only that is a catch what you need to do. And how much is the overlap length, that is given, not overlap, that is yeah, this is 600 additional length you have to consider. Okay, this much BBS you can do. I'll explain you once again what you're supposed to do. See, how you'll find the development, how you'll find the bottom bar for this. It is very simple. Okay, this length you can find, no, this clear span you can find from where, from here to here you can easily find it. This is clear span. Then this width, next you have to find this one. How you will find this? Whatever is the width of your column, from there you deduct one cover of the column, that is 40 so you'll get this length. Okay, similarly here also you can do whatever is the width of this column, from there you deduct one column cover, you'll get this one. And regarding this one, that is this portion, regarding this portion, you know how it has to be done. They will give you the development length. So whatever the development length is given, in that the red color portion is already taken care of. Whatever is left out, you have to do this. If that is not given, then you know whatever is your depth of the beam. From there, you deduct the top cover and the bottom cover. Okay, and then you multiply. You take 2/3 of that. Then also you'll get this. Otherwise, usually they give development length, which we used to do. This is 57 times the diameter of the bar. This I have found. So 57 times the diameter of the bar minus, if I do this one, I'll get this one. So this you can find. Similarly, whatever you get here, no, the same thing will be here. So this BBS can be done easily. Okay. Now, when you start the BBS for this on the other side, it will start in this way. Okay. This also remains the same. So this bar has to be taken up to here. So how you will find the cutting length of this? Cutting length will be very simple. What you do, you take the length from here. See, you know this length, isn't it? This length can be found easily from the face of this column to this outside. You can get the length. How you can get the length? It is already there in the drawing, or you can do that calculation from the AutoCAD. This length you will be knowing. Let us consider this length. I'm taking some random value, which is 4.5 meter, or let us say 4500 mm. Now, for that, what I'll do, I'll add the width of the column. I'll add the width of the column. And again, this 600 mm extension they have given. That means from the face of your column to how much extension it has to happen. It is mentioned 600 mm. That's it. So 4500 plus the width of the column plus 600 if I do, I'll get the total cutting length of this bar. Very simple. This you can do. So this usually comes when you have a two beam having a different depth. Okay, got it. So that is why I wanted to explain this part. So that is why I took this as a a kind of a complicated beam. Otherwise, the rest things remains the same. Finding the cutting length, everything remains the same. Only the thing is you cannot take the bottom bar completely. Your bottom bar will stop here, and this bar will come from here. This is one change which you need to understand. Similarly, you'll get different bars like that. So based on that, you're supposed to do. Okay. Let me check if I have any other beam similar to that. Yeah. Other than that, rest all beam sizes are same. Whenever there is a varying depth, this is how we are supposed to do that. Okay. Yeah. This is one more drawing where the same thing has happened. See, this beam depth is 230 by 450, whereas this beam is 230 by 380, 380, 380. So there is a variation in the depth. So that is the reason you see the bottom bar, it has come like this, and then it has come like this, and it has gone like this. Okay. And the other bar, how they have done it exactly. The other bar, they all have started from here and it has gone like this. So how much is this extension, the green color, which has extended from here to here, that will be mentioned. Here it's not mentioned, but usually in the drawing they are going to mention. Based on that, you have to prepare the BBS. Rest all things remains the same. Okay. So whenever you have a beam of different depth, this is a kind of a drawing what they give. And you know the reason, because 450 level will be here and 380 level will be here. So then when you pass your bottom bar, your bottom bar cannot be bent and taken to the top. So what we do, we stop our bottom bar here only, that is 450, and 380 bar will be taken like this. It will overcross. Okay. That is why you can see the same thing happening here. Yeah. Rest all things you can do. There is again same thing here also. This is 380, this is 450. So you see how the bar has come. This bar has come here. This bar has come, and then since it's a 450, they have taken like this. Okay, 450. Then the 350 bar, I mean the 350, 380 depth bar will start like this. Okay, it will go like this. Whereas top bar will be a continuous only. Top bar, because the level will be same, no? So top there won't be any difference. Top will be same like this. It will come. Only bottom there will be a difference. Got it? So this is one thing which I wanted to tell. Other than that, rest all BBS you can do on your own. Yeah. Now another question. Sometime what happens? Sometime what happens? If I go to the general drawing, I already explained you this. Yeah. So this is a typical. What is that? Layout what you get. Okay. Suppose see now what has happened here. Sometimes all the structural consultant will not give you that how much is this top extra bar and all. Like here they are mentioned, isn't it? Where is that? Yeah. Here these people are mentioned. From here it is 800 mm. From here it is 880 mm. And then here you can see top left extra is 1255 and all. 1255. But few people don't. Few of the consultant they don't give that. So in that case, what you're supposed to do, you get something called as a general drawing. So in the general drawing, you always remember, okay, your top right extra, your top left extra should be 0.3 into L1, and your top right extra also should be 0.3 into L1. Getting my point? So this is 0.3 into L1, or even you can, some people take this as L by 4 also. Some people take this L by 3 also. L by 3 is 0.33, which comes out to be 0.3 into L1. Some people take this as 0.25 also. That is also correct. So it's totally depending on the consultant who is giving you the drawing. Suppose if it doesn't mention, then you can refer a general drawing. You ask him for a general drawing, and based on that, you can do the calculations. Okay. Okay. That is how you're supposed to do. And where here L1 is a effective span. And L1 is the effective span from the center of this column to the center of this column. So if you want, I can take one example. Let us consider my effective span is 5500. Okay. Then what will be my top left extra? You just tell me What will be your length of this top left extra? Top left extra, this one. How much will be this one? Top left extra. So what you do? You just take the formula 0.3 into 500. And 500, it should be from effective, from center of the column to the center of the column. So 0.3 into 5000 you do. It will be 1500. Finish. You got the answer. If somebody asks you what should be the green color length, it is 1500. Same here also, it will be 1500. Okay. That is how you are supposed to do. And based on these calculations only in your drawing, all these things were given. How did the person get 1255? He took it 0.3 into this value, so he got 1255. Now again, 0.3 is not constant. Some people give L by 4, some people give L by 3, some people give 0.3 and all. Okay, based on that you are supposed to do it, but I've explained you how those things will come. Yeah. Then other than that, the bottom part, again for the bottom also same thing is given. So bottom curtailment bar, you can see, no, this is my bottom curtailment. This is good, but from here how much gap I should leave? Okay, and from here how much gap I should leave? Again, that is mentioned. It is mentioned from the face of your column, leave 0.15 into L1. From here also you leave 0.15 into L1. That means what is 0.15 into L1? So 0.15 L1 we took 5000, no, effective span. You do that. How much it will be? 0.15 into 5000. So it is 750 mm. That's it. So you got this 750. Here also it is 750. So what you'll do? So if they ask you what is the gap from the face of the column, you have to leave 750 and start your bar from the face of your column. And from here also you have to leave 750 and start your bar. Okay. So how did they get 750? They took 0.15, 0.15. Okay. Good. Now that is why practically whenever you see the drawing, you see here. Yeah. This is a good example. This bar is a curtailment bar, isn't it? This bar is a curtailed bar. So this distance is how much? From how much you have to leave? So you have to leave 850. How did they get 850? They took effective span, that is 5020 multiply by 0.15. If you do, you should get 850. Let me do that. So 5020 into 0.15 if I do, I'm getting 753 because our effective span is from center to center. It will be center to center. Let me do that also. 5020 plus 230 into 0.15. Still it will not work out. The reason is all the time this won't be 0.15. Say again, you need to understand. We have taken 0.15. Few people take this as 0.17. That means they take L by 7 also. So it totally depends. But whatever is given in a general drawing, you can follow that. There is no, a problem with that. Yeah. Okay. That's it. That's it. Other than that, I think rest all things I've explained. Yeah. Now the last question is that, so I told you in the beam, they are going to give you the development length. For example, here, see what we used to take. This was my development length, isn't it? From the face of the beam to this one, we used to take this as development length, which was 57 times the diameter of the bar. According to our calculation, whatever we did, 57 into dia of the bar we used to do. Suppose in some of your local projects and all, people don't give all these things. Then what you do? If they don't give you the development length, your calculation will be very simple. I'll explain you for one beam how it has to be done. Okay. I'll take one simple beam from here. Yeah. I'll take for this beam. Let me take only a single beam. For this beam, I'll tell you how it has to be done. Just concentrate on this. Okay. Nothing else you have to look. Yeah. Leave it. Fine. So how you will find this development length that I want? This I want you to find. This you want to find. This I want you to find this one. This development length. How you will find? It is not 57 times the diameter of the bar, or maybe in your drawing that is not at all given. So in that case, what you do? Very simple. First you find outer to outer bar. First what you do? You find this thing, which is that clear span you find. Okay. From here to here, you find the clear span first. How much is that? It's already given 4765. Done. Next, what we'll do? We'll find this one. From here to here, we'll find. And from here to here, we'll find. How you will find that? Very simple. We know the width of the column is 230. We know the width of the column is 230. So what we do? Whenever we take the green color bar, we don't take it completely. Whatever is a column cover will deduct it. No, from 230 I'll deduct 40 mm. From 230 I'll deduct 40 mm. So it will be 190. So this will be 190. I'll write here. This will be 190 mm. This also will be 190. So if the development length is not given, you have to follow this method and it will be correct. Now the main question is how to take this one. These things already understood, but how you will take this one? And how you will take this one? That is a big question, right? You don't have development length. If you had development length minus 190, would have given you the blue color. Now what you do? There are certain construction practices. What we do is, whatever is the depth of your beam, whatever is the depth of your beam, you take that and you multiply 2/3 of that. That's it. Finish. What do you mean by that? Simple. What is the depth of my beam? So my depth of the beam is given here. Okay. My beam, it is 450. 230 by 450. So what you do? 450 multiply by 2 by 3. 2/3 of the depth you take it. That's it. So that itself will be that L. This portion. This portion. So 450 into 0.67 I do, because 230 is 0.67. So 301, I'll say 300 mm. Finish. That's it. So this will be 300 mm. So this will be 300 mm. This also will be 300 mm. Okay. Now you'll ask me one question, sir, from what is the logic behind this? So there is no logic. These are the certain construction practice what we adopt. Otherwise, there is one more logic. Whatever is the depth of your beam, deduct the top cover, deduct the bottom cover, and take that. That is one way of doing. Else, whatever is the depth of your beam, from there you deduct one top cover, one bottom cover, and then you take the 2/3. Like for footing, we used to take that L, no? Same thing you can follow for the beam also. This is a normal construction practice what we do. Usually, in a bigger construction company and all, they usually give you the development length. Then you can follow that. If the development length is not given, when you work for a local projects and all, usually they don't give you the development length and all. Then how you will calculate the BBS? You follow this method. This depth, whatever L you are going to keep, no, in the beam, this L, what you do? Overall depth of the beam into 2/3 you do. Whatever answer you get, like 450 is the overall depth, into 2/3 I got 301, so I took 300. So this I'll keep 300, 300. That is sufficient. Not an issue with that. Okay, that's it. But you should not give it too much small. Too much small you should not give. Then your beam becomes a simply supported beam. Okay. So whatever is that 2/3 you give, not an issue. Okay. That's it. Yeah. So with this, I think most of the complicated things in the beam BBS, all the things I've addressed here. There's nothing left. Let me check out. Yeah. Development length portion I've explained you. Then whenever there's a different depth of the beam, that is also covered. Then these things also I've covered. Okay. About the general notes. Previously, we used to take development length. Sometimes due to earthquake resistant structures, they give you LD plus 10 times the diameter of the bar. Based on that, you do that. This is already addressed in my previous lecture. Whenever there is a, what is that, earthquake resistant structure coming up, detailing is done according to 13920 code book. What we do, you take development length plus 10 times the additional diameter we take. Okay, fine. So that is also explained. And everything is explained. Suppose if nothing is given, then you get a general drawing. Based on that, you take this L by 3 or 0.3 into L1 and all. Okay. Yeah. So I think almost everything I've covered in the beam part. There's nothing left out. All the complicated beams, everything has been taught here. Okay. Great. So I hope you have enjoyed my lecture up to here. Try to practice the beam BBS. It's very simple. Okay. So only, yeah, there will be one more complications in your BBS. I'll explain you that also. Okay. So complications will be something like this. Yeah. Now, in beam, we did not do any lapping much, right? We did not do any lapping much. Now I'll show you where the lapping will come. Now look here. Here I can give you some examples of lapping. Hmm? But usually, I'll tell you, usually this kind of detailing no one will give you. Whenever we as a structure consultant do the designing, I'll provide a 16 diameter 2 bar completely. I don't provide a 12 diameter 1 bar, and then I'll not provide a 16 diameter. Then I have to do the lapping. So here you can see the same problem happening. Maybe here, or I'll show you one more. Okay, but this is too much complicated. That's it. Okay, I'll explain you what is the complications here. Yeah, we'll wind up this. I mean, this is not required. Only up to this part I'll take it. Okay, this is not required. Leave it. See here, this guy is providing a 12 diameter 3 bar. This is your 12 diameter 3 bar. Then after that, you are going to you're going to provide a 16 diameter 3 bar again. That means you're doing a lapping here. And the 16 diameter 3 bar will go continuously. Then again, in the middle portion, you're putting a 16 diameter 2 bar. Okay. And then again 16 diameter 3 bar. Okay. So what is happening here? What is happening here? Here it was 12 diameter 3 bar, but suddenly there is a lapping coming. Even though the bar is not going more than 12 meters, still you have to provide a lap because you're lapping a 12 diameter and 16 diameter. Then you need to add one lap length here. So that is why usually we don't give a detailing something like this. So this detailing is not a good detailing. A good consultant has not given this. Usually when we give a drawing, we say 16 diameter 3 bar throughout or 12 diameter 2 bar throughout. We don't give 13 diameter 2 bar, 12 diameter 3 bar, and then we'll not lap a 16 diameter 2 bar and all. It's a very tedious work on the side. Okay. So how you will do a BBS for this? So BBS for this is you have to consider 12 diameter 3 bar. Okay. And you first have to find the length of this. Now where you will stop this? So always, whenever you do the lapping in the beam, you should know the concept. If you are lapping a top bar, you can do the lapping in middle. Okay. Now we are speaking of the top bar only, no? What is the middle portion? 19, this is 1915. If I divide it by 2, will I not get exact the middle of this beam? So middle I can do the lapping. That means this length, how you'll find now? I want this length to be found. This length. How you'll find this length? How you'll find this length? You don't have anything given from here to here. Nothing is given. So what you do? What you are supposed to do? It's very simple. Nothing. Yeah. First you should know how much is this one. So this is 450. Wait, let me do it properly only. See, all this are little time consuming. Okay. This will be orange color. Then your development length, I'll take a red color. Okay. Then the remaining portion, I'll go with a green color up to here. Okay. Now you tell me how you'll find this. So this you can find. Red color you can find. You know 450. 450 minus 40. One cover, I'll 410. So this will be 410. This is simple. Now this orange color, how you'll find? Orange color, simple method I'll adopt. 380 is the depth of my beam. I'll take 2/3 of that. I'll get this one. Okay. Just now I explained you. I'll write it here. 380 into 2/3. 2 by 3. How much you'll get? Do it. So 380 into 0.67. 254 I'm getting. You can take 250 also. No problem. Okay. Practically no one will give 254. So always make a good figure. Make a round figure. Go for 250 mm. Okay. Fine. So I'll write the calculation here. And this I'll write 250 here. Okay. Fine. Now the big question. How much is this one? The big question is, how much is this one? From here to here, how much? Even I also don't know. Simple logic will apply. We know that lapping will be done in the middle for the top bar. So this is a span what I have. No, 1915 is a span of this beam. Only this beam. What is half of that? Half of 1900 is 1000 is 900. 900 I can do. So I'll take this as 900. You can take anything. You can take anything, but you should exactly half it, right? Whenever we do the lapping, we lap at the center. So 1915, I'll take 1900 only. If I divide it by 2, how much it will be? 1900 divided by 2. It is 950. So you can take 950 or even you can take 900. It doesn't matter. But make sure if you're taking 900, you have to cut the bar 900 on the side. If you're taking 950, take 950 on the side. But I'll take 950 only. So this will be 950 for me. 950. Okay. Got it, no? You're able to understand. So this length, I'll cut 900. This will be 900. This will be 410. This will be 250. So in this way, I'll provide a 12 diameter 3 bar. So this my 12 diameter 3 bar will go. After that, once I reach here, I'll lap this with a 16 diameter 3 bar. And my 16 diameter 3 bar will go continuously. So this is my 16 diameter 3 bar now. 16 diameter 3 bar. 1, 2, 3 bar will come. Okay, 3 of 12. 12 diameter 3 bar will get lap with 16 diameter 3 bar. In this way, it will lap. Where the lapping will happen? Exactly at the center. Okay, exactly at the center, the lapping will happen. Okay, so again, this bar will go straight like this. And then, of course, once it reaches here, only 2 bar will go in the center. Again, from here, another 3 bar will come. So it's a very, difficult BBS. The drawing itself is not good. It's very difficult to a BBS for this. But still, I'm teaching you how it has to be done. But drawing something like this, if you give on the site, no, the site engineers and or everyone is going to shout at the structure consultant, and he'll never get a project in his life. So you should not do a detailing something like this. Try to give it more economical. It's okay. Provide a 16 diameter 3 bar throughout. Our calculation is also simple, and on the site the execution can be done in a better way. Okay. Now you lap the 16 diameter 3 bar here. Okay. So only one change will happen. You'll have to add the lap length, which is 50 times the diameter of the bar. 3 times you have to add it. I mean, not 3 times. For one bar, it is 50 times the diameter of the bar you have to add. Okay. That's how you're supposed to do. But again, this is a very rare case. You never get, beam where you do a BBS something like this. It's a very, what do you call, very bad way of detailing all these things. Okay. Such projects will get very delay in execution, and the consultant will never get any other chance in his life to do the project, because no one will appreciate such kind of drawings. So always better you try to give a very good drawing. See, this is good. 16 diameter 3 bar he has given throughout, and your top left extra will be 12 diameter 2 bar, 12 diameter 2 bar, and here it will be a 16 diameter 3 bar. You can do a BBS for that. And bottom is always a 16 diameter 3 bar continuous, and here it will be 16 diameter 2 bar. Okay, this is good. So in this way, if you do, it's a good detailing. Yeah, yeah, that's it. So I think most of the things I've explained, that's how it is. And other than that, the lapping concept and all will come, but that will actually come from site execution point of view. In BBS, you don't have to worry about the lapping much. Okay, in BBS you can do the lapping, but practically on the site when you provide the bar, no, you cannot provide the lapping of all the 3 bar in one junction. You have to alternate it. Okay, so what I'm trying to tell, let me give one example for that, because you should know that also. For example, let us consider let us consider I'm doing a beam. Okay, let us consider this is a beam what I have. Hmm? This is a beam what I have, and I need to provide a 16 diameter 3 bar. So how you will provide a 16 diameter 3 bar? So I'll start 1 bar from here. This is my first bar. Okay, it will go like this. It will end here. I'll do the lapping now. This is first bar. Okay, I'll bring the second bar. I'll do a lapping. I'll take it like this. This is done. This is first bar. Okay, imagine first bar I have kept. Now next bar also I'll take. Again, next bar I'll not do like that. Next bar I cannot come and lap it here only. Next bar I cannot lap it here. I cannot lap it like this. Okay, it will not work out on the side. Cutting length will remain the same, but this lapping concept will not work out, because the code says that not more than 50% of the bar has to be lapped at one section. That means if I have 3 bar, only 1 bar or 50% is 1.5 bar, or only 2 bar I can lap at one same section. I cannot lap all the bar at the same section. So next bar, what I'm supposed to do, I'll not start from there. Next bar, I'll start from here. Okay. Next bar, I'll start from here like this. I'll end somewhere here. I'll end somewhere here, this portion. And now I'll lap the next bar. This is from execution point of view. It has nothing to do with BBS. Next bar I'll take like this, and I'll do it like this. After that next bar, when you take, you can take next bar like this. You'll take next bar here, bring it here, and then at this point only you can do the lapping. Okay. Now you see 3 bars I'm providing. Out of 3 bar, how many bar did I lap at this junction? Only 1 here and 1 here. So not more than 50%. No, I mean 2 bar you can say. Out of 3, only 2 bar are lapped here. Whereas at this junction, only 1 bar are lapped. There is no lapping here. There is no lapping here. So practically on the side, this is how you are supposed to carry out. Cutting length for all the bar remains the same. But on the side execution point of view, you need to take care of these things also. Okay, got it? No. So I hope you are able to understand how this BBS has to be done. So this problem usually comes when you have a long span. See, if your span is less than 12 meter, there is no point in lapping, because bar available itself is 12 meter, doesn't matter. You have a span, you have a continuous span, which is almost, let us say, 30 meter. So in that case, obviously the two lap will come, and you have to arrange that two lap in such a way that it will not, intersect at one junction. All the bar will not intersect at one junction. You have to alternate. You have to do the staggering of the lapping. Okay, so that is a site execution point of view. But still, I've explained you how it has to be taken care of. Okay, yeah. In spite of this, if you still have doubt, not able to understand what I was actually trying to tell, you can always get back to me on this number. Okay, so you can WhatsApp me. So it will be +1 here. Okay, +1 99537790, or you can mail me on AKSHAYKMATS73. So I'll be there to help you out, maybe with a better picture or something like that, just in case if you're not able to follow what I was trying to tell. Okay, yeah. So we'll see you back in the next lecture. Thank you.